Welcome everybody to part 3 of our notes on climate change and global warming. This is a retake. The first one wasn't working too well, so I thought I'd redo this set of notes. Now, what are the greenhouse gases? Well, carbon dioxide by far is the #1 greenhouse gas that we have in the atmosphere. 54% of our greenhouse gases are carbon dioxide, or CO2. Methane, which is CH4, is approximately 12%. Then we have CFCs. That's the easy way to say chlorofluorocarbons. You can just call them CFCs. It's 21%. Nitrous oxide is 6%, and ozone is 7%. Now, when we look at the greenhouse gases, again, by far, carbon dioxide is #1. Then we have your CFCs, your methane, your ozone, your nitrous oxides, and all those combined make up approximately half as well. Now, when you look at this and you start to think about the atmosphere, you might think back to what your science teacher once talked to you about. And you might be thinking, well, didn't they say that nitrogen was the #1 gas in the atmosphere? And you would be right. 78% of the gas in the gases in the atmosphere is nitrogen. And then oxygen is almost 21%. And then you have that little sliver of everything else. And when we look at it over here on the side, you see argon at 0.934%. You see water vapor. Then you come to carbon dioxide, 0.035%. So even though we look at this and say, well, carbon dioxide is 54% of the greenhouse gases, that's important to notice. So when we look at a percentage of the entire atmosphere, carbon dioxide is really a small percent of the total atmosphere. Then when we look at methane, and then we go down to things like ozone, CFCs, look at this, 0.0000001% of the atmosphere. So we're looking at a very small part of the total atmosphere. But what scientists worry about is these gases, even though they're a small percentage of the total atmosphere, they seem to have a pretty big impact on the atmosphere. Now, normally, greenhouse gas in the atmosphere is fine. At normal levels, it's actually good for our planet. But what we're worried about is this right here, where we have abnormal levels, where we have an increased amount of CFCs, an increased amount of CO2 and nitrous oxides and CFCs. So if we get too much of it, it could tend to overheat our planet, or at least get to the point where the planet's not advantageous, the temperature is not advantageous for us as humans. Now, I want to talk about one technicality. Technically, water vapor is the most important greenhouse gas. However, we as humans have very little control over it. We can't control the amount of water vapor for the most part in the atmosphere. So when we talk about greenhouse gases, if I ask you a question on a test, what is the #1 greenhouse gas that we as humans cannot control? You would say water vapor. But if I said or asked you a question, what is the #1 greenhouse gas in the atmosphere that humans have a lot of control over? That's where you would say carbon dioxide. Now, carbon dioxide, let me adjust this a little bit. When I moved into GDocs, kind of threw things off a little bit. Here we go. Carbon dioxide, or CO2, is the greenhouse gas humans are influencing the most. And here's an interesting fact. Each year, 20 tons of carbon in the form of carbon dioxide, roughly the mass of 4 adult elephants, are added to the atmosphere for each person in the United States. So remember, when you exhale, you're releasing carbon dioxide, and other things you do release carbon dioxide as well. If we were to take all that carbon and we were to put it in a giant balloon, eventually over the course of a year it would equal 20 tons. So that's a lot of CO2 that we're putting into the atmosphere. Now, carbon dioxide is naturally in air, but humans have dramatically increased the level of CO2 since the Industrial Revolution. We continue to emit carbon dioxide into the air with cars, manufacturing, the burning of rainforests, and the cutting down of trees. So here's a graph, and this looks at carbon dioxide levels from the 1960s to about 2010. So you can see it has gone up dramatically. Here's another interesting thing. Here, this black line right here is taking a look at carbon dioxide levels, and you can see that they're going up, and this goes from about 1880. Now, the interesting thing, the blue here shows the average temperature below average, and the red shows that the average temperature has been above the average. So when we go back, 120, 140 years, we can see that as the carbon dioxide levels seem to go up, well, they're going up. As they're going up, it seems that we're getting more and more above normal temperatures. So one of the things scientists are theorizing is that there is a direct relationship between CO2 levels and temperature here on our planet. So again, what are some of the sources of carbon dioxide? Power plants, automobile vehicles, cars, trucks, buses, the burning of forests. Now, the destruction of trees actually create a shortage of plants to remove CO2 from the air. And there's some research out there that's saying that as we get more and more carbon dioxide in the atmosphere, plants will actually start to grow better. So I guess there is some good with that. However, are we going to be able to produce enough plants to offset the increase of carbon dioxide into the atmosphere? And that's where scientists are thinking we're probably not going to be able to do that. Now, we also release CO2 into the atmosphere when we burn fossil fuels for the generation of electricity. And in the last 200 years, CO2 levels have risen almost 30%. Now, there's some research out there that shows that you can actually take the carbon dioxide out of the atmosphere and you can test it and you can see what's the source of the CO2. Is the source you, me, maybe exhaling the CO2? Or is the source of CO2 coming from coal? And remember, coal once was a sink for carbon dioxide. Remember, coal came from dead plants, and that coal was sitting in the earth, or oil was sitting in the earth, and that carbon dioxide was sitting there. That carbon was in the earth. Now all of a sudden we take it as humans and we burn it. Now all of a sudden that CO2 is released back into the atmosphere. It all goes along with that carbon cycle. So let's move on to methane. Methane is another natural greenhouse gas. It's created naturally from a decomposing matter in swamps. Methane is used in industries as a starting material for many different chemicals. Methane also comes from cow gas, coal mining, natural gas fumes, landfills, wood burning. And in the last 200 years, methane levels have increased by 145%. So we can see methane is another one of those gases that was always naturally in the air, but it seems as humans, or at least human activities, seem to be increasing the amount of methane that's in the air. Again, some sources: fuel production, wetlands, and growing rice cultivation tends to increase the amount of methane. You wouldn't believe it, but termites, cattle, goats, camels all release a tremendous amount of methane into the atmosphere. So here's a graph, and what it's doing, it's taking a look at two things. The green line is actually looking at population, and the blue is looking at methane concentrations. So it seems like there's a direct correlation, a direct link between humans and methane levels. Now it's not saying that humans are directly creating all this methane. In other words, we're passing gas. But if you think about it, if we go back here, the more humans we have, the more fuel production we have. The more humans we have, the more rice cultivation we have. The more humans we have, the more cattle, the more goats, the more camels we have. So as we get more and more humans, we get more and more of all these other things. And so that's what this graph is showing. As methane levels increase dramatically, as livestock is increasing dramatically, as human population on this side is increasing dramatically, methane levels are increasing dramatically as well. So next, let's talk about CFCs, or chlorofluorocarbons. Now these are 100% humans caused, and that's because they were never naturally in the air. This gas was used mostly in aerosol spray cans, things like spray paints, hairspray, and as a refrigerant for air conditioners, cleaning solvents, even packaging materials had CFCs in it. So when scientists first discovered CFCs, it was, wow, this is a neat chemical. It does all these great things. Well, it took a little while for us to figure out that CFCs might not be as good as we thought they were. So using CFCs in aerosol sprays has now been banned in the United States and in most other parts of the world. So CFCs, for the most part here in the United States, aren't being used. Some companies still use them, but what they have to do is they have to recycle them and then use them over and over and over that way. And most companies have moved on and they found other chemicals or other combinations of elements to create these chemicals that don't do as much harm to the environment. Some sources of CFCs again, insulating materials, aerosol sprays, and again, it's been banned, so now if you use spray paint, you don't have to worry about it. And a lot of refrigerants. Nitrous oxide is another gas that's emitted into the atmosphere mainly by human actions. And a lot of times this happens during agricultural and industrial activities, during the burning of solid waste and fossil fuels. Now, if you see nitrous oxide, usually when I ask students, what are the two things or what are the two places you've heard of this? A lot of times say, oh, when we're racing a car, a lot of times they'll have a bottle of nitrous oxide and it'll give the car a boost. That's correct. Or you might have seen this at the dentist's office. A lot of times they'll use this as laughing gas. And in the last 200 years, nitrous oxide levels have increased by 15%. Again, sources of nitrous oxide, you're going to find it naturally in soils, but you're going to find it in the burning of fossil fuels, in oceans, in chemical fertilizers. So again, there's some natural sources, but there's also human-created sources as well. So nitrous oxide budget. Again, there's lots of different budgets out there. We talked about the heat budget and the energy budget. So there are sources, there are sinks for nitrous oxides. Now, each greenhouse gas differs in its ability to absorb heat in the atmosphere. Now, CFCs are actually the most heat absorbent. And methane traps over 21 times more heat per molecule than carbon dioxide. And then nitrous oxide absorbs 310 times more heat per molecule than carbon dioxide. So let me use this in an analogy. So at night, do you cover up? Most of us cover up, especially in the winter. Now in the summertime, do you cover up? A lot of times people just cover up with a sheet. Now, when you go to bed, unless you have an electric blanket, what produces the heat to keep you warm at night? If you're saying the blanket, your body actually produces the heat. Now in the summertime, you might just cover up with a sheet, and that sheet's really thin. It doesn't trap a lot of heat close to your body. And that's good in the summertime because you want your body heat to go into the room so you stay cooler. Now in the fall, when it starts to get a little bit colder, you may cover up with a sheet, but you also may cover up with a blanket. And the whole idea with that is that that blanket will trap more heat. Well, your carbon dioxide is your sheet. It's not going to trap a ton of heat, but it's going to trap some heat. And then you have that thin blanket. That thin blanket may be your methane, where it's going to trap 21 times more heat per molecule than carbon dioxide. So it's going to trap more heat. But when you get into the winter, you're getting really cold. You want to trap a lot of heat. So what do? You throw on a really thick blanket. And that thick blanket might be your CFCs or it might be your nitrous oxides because they're going to trap a lot more heat than a simple sheet or a simple blanket. You know, a big thick quilt's going to trap a lot of heat. So these molecules tend to trap a lot of heat as well. Now, if you have any questions about the greenhouse gases, be sure to ask me in class. I'd be happy to answer any questions that you have. Thank you.